miniskirts, the mini miner, and of course the moon landing.
Achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth. No single space project in this period will be more impressive to mankind or more important for the long-range exploration of space, and none will be so difficult or expensive to accomplish.
But many people wanted to know if this massive amount of cash being spent to put men on the moon was really worth it. After all, what possible use could be made of the moon once we'd got there?
Since Kennedy made his historic speech 8 years ago, nearly $50,000 million will have been spent towards landing a man on the moon. This whole vast project has been pursued with a single-mindedness normally preserved for war. And yet the real objectives behind Kennedy's momentous decision remain to most people obscure. But the moon does offer great opportunities for scientific experimentation, particularly for high-powered astronomy away from the Earth's atmosphere.
When you look at the faintest objects in the universe, the Earth's atmosphere is giving off its own light. And so as things get further and further away, and therefore fainter and fainter, you stop seeing them from the Earth. The moon would let you see further out in space. That means further back in time. So you could probably distinguish between the two theories of how the universe itself came into being. And this is probably the most fundamental question one could ask in astronomy. The whole question of cosmology, perhaps the creation of the universe, is the most fundamental question man's curiosity could ever ask about his universe. And it seems to me that an astronomical base on the moon could give us the answer to that question.
A plaque on the lunar module reads, "Here, men from the planet Earth first set foot upon the moon, July 1969 AD. We came in peace for all mankind."
The reason why scientists were prepared to go to such length to try and settle matters once and for all was that although the Big Bang seemed to be winning the two-horse cosmological stakes, there were still some things the theory couldn't explain, like how galaxies formed. And as problems went, this was a big one. Hoyle and the Steady State Stable reckoned that the Big Bang would have been such a powerful explosion that it would have produced nothing but a homogeneous hot fuzz. And that's a problem because for stars and galaxies to form, there would need to be imperfections in the amorphous soup of the Big Bang, tiny variations, some regions that were slightly denser than others. These slightly denser regions would gradually attract more and more matter until eventually the first galaxies emerged. To stand any chance of finding these tiny variations, scientists had to go back to Penzias and Wilson's background radiation. If there were any imperfections in the hot fuzz of the Big Bang, they should also be observable in the background radiation. But the problem with the background radiation is that its signal is incredibly faint. Impossible to accurately decipher any unevenness through the Earth's atmosphere. In the late 1970s, a group of enterprising scientists thought they'd solved the problem by borrowing a high-flying U-2 reconnaissance plane legendary for its Cold War spying missions. Now they were able to spy on the early universe.
In 1977 and 78, a new reconnaissance in detail was carried out by a group at Berkeley. They flew high in the air in an old U-2 spy plane.
It's on at 2350.
All right. Turn the tape recorder on.
Okay. Yep, that's on.
All right. We're reading on scale, and we're reading plus 18.
Okay, plus 18.
All right. Now turn the rotation system on.
Okay.
The U-2 is fitted with a pair of open receiving horns. They're small ones matched to millimeter waves. Their task is to scan the sky, comparing one direction with another to see if the signal shows any sign of directionality. True heat radiation is free of all directional detail. It is seamless and bland, uniform in every direction, the sign of an utterly uniform fireball long ago. The horns rotate to exchange places and cancel out any inbuilt bias. The sky is all but black in the thin air 13 miles high, where the U-2 flies above most of the atmosphere. Professor Richard Muller tells of his results.
On the first few flights that we had, we could begin to see that the uniformity of the radiation wasn't perfect. There were features. By the time we had several flights spread out over a year, the pattern was making itself evident. There was a most intense region. As you look off in the sky, it's in the constellation of Leo. And very significantly, the least intense region was 180 degrees away in the constellation Aquarius. What's more, the variation between these regions was very smooth and uniform. This gave us a very ready interpretation of what was causing it, and in fact it was not an intrinsic variation in the background radiation itself, but was due to the motion of the Earth through the background radiation.